Okay, Algebra 2, we're going further into our factoring this week. Last week, we factored by taking out the greatest common factor, right? So for example, 8x squared minus 20x equals 0. We want to know what number do we put in for x to make this equation true. So we factor by taking out the greatest common factor, which in this case is 4x. When I take 4x out of 8x squared, in other words, when I say that, I mean when I divide 4x into 8x squared, 8 divided by 4 is 2. X squared divided by x to the first, you subtract the exponents. 2 minus 1 is 1, so there's 1x left there. When I take 4x and divide it into 20x, I get 5. Another way to make sure this is correct is if I would distribute the 4x back through, I want to make sure I get 8x squared minus 20x, and I do. Now that I have a product, 4x times 2x minus 5 equals 0. This only works because it's equal to 0, okay? We set our quadratic equation equal to 0. We factor it. Now I have two things that we're saying multiply together to get 0. The only way two things can multiply together to get 0 is if one or the other or both are 0. So this allows me now to make up or to write and solve two smaller equations. Either 4x is 0 or 2x minus 5 is 0. So I'm going to divide by 4. And 0 divided by anything is 0. So x is either equal to 0 or I'll add 5 and divide by 2. So my two answers are 0 and 2.5. Okay, that's what we did last week. Interestingly enough, we also graphed last unit. We graphed a parabola. And if I would graph y equals 8x squared minus 20x, okay, if I would graph this, y equals 8x squared minus 20x, instead of y equals, we did equals 0. So let's look at where this graph does equal 0. It equals 0 right here, and it equals 0 right here. Right? That's when the graph, the y would be 0. No, so, isn't that what we got? X equals 0, and x equals 2.5, right? Between 2 and 3. Okay? So the answer to this relates to the graph in that we're looking at y equals this quadratic, and we're looking at the x-intercepts where y would be 0. Algebraically, I got 0 and 2.5. And graphically, I see that 8x squared minus 20x would equal 0 at 0 and 2.5. Let's try this one. 9x squared minus 64 equals 0. Try as I may, I can't find a common factor. What goes into 9? 3. Does 3 go into 64? Nope. 9. Does 9 go into 64? No. So they both don't have x's, right? This has an x squared. This doesn't have an x. There is not a GCF. I guess that means there isn't an answer. When I graph it, I see there are answers. There is a place where 9x squared minus 64 is 0. It's here between negative 2 and 3, and here between 2 and 3. There is an answer. Okay? I just have to figure out a different way to factor this. All right? And that's what we're going to be doing this week. 9x squared minus 64 is a binomial that's called the difference of two squares. Okay, that's what that one's called, the difference of two squares. And I want to show you where that comes from here with some other examples. Could you do me a favor and multiply 3x minus 8 times 3x plus 8? Go ahead and do that on your piece of paper or on your notes. x plus 5 times x minus 5, 4x minus 1, and 4x plus 1. Pause me and multiply those together. Okay? When you come back, I'll do it for you. But please try it on your own first. All right. Hopefully you paused me, and now you're back. 3x times 3x is 9x squared. 3x times 8 is 24x. Negative 8 times 3x is negative 24x. Negative 8 times positive 8 is negative 64. So then I combine my like terms, 24x minus 24x, well, that's 0. So this ends up being 9x squared minus 64. Okay? The next one, x times x is x squared. X times negative 5 is negative 5x. X times positive 5 is positive 5x. And then a positive 5 times a negative 5 is negative 25. I notice that these terms cancel out to 0x again, so I get x squared minus 25. And the next one, 4x times 4x is 16x squared plus 4x minus 4x. See the pattern here, gang? Negative 1 times positive 1 is minus 1. They cancel. I end up with 16x squared minus 1. 16x squared minus 1. Okay, our goal is to be able to see these as the questions, what I just circled, and we need to be able to go backwards to solve quadratic equations that are in this form. Okay, I'm going to have to be able to look at 9x squared minus 64, which was our problem we had in the beginning, and notice, hey, there's no greatest common factor. However, how are we supposed to know that we could factor that into 3x minus 8, 3x plus 8? X squared minus 25. They have nothing in common, but yet I'm going to have to know that I can factor it into x plus 5, x minus 5. 16x squared minus 1. Nothing in common, no greatest common factor. But I'm going to have to realize, hey, I can factor that into 4x minus 1, 4x plus 1. Hopefully you're seeing that the way you know that you can factor it is, first of all, these are perfect squares. The two terms that you're adding, or that you're, I'm sorry, the two terms that you're subtracting are perfect squares. The square root of 9 is 3. The square root of 64 is 8. Okay, and of course the square root of x squared is x. So we have 3x and we have 8, once with a plus, once with a minus. Doesn't matter which one is first. Here the square root of x squared is x. The square root of 25 is 5. We have an x and a 5, once with a plus, once with a minus. Here we have two terms and our subtraction sign. Perfect square 16x squared, perfect square 1. The square root of 16 is 4, so we have 4x and 1, once with a plus, once with a minus. These are called the difference of two squares. It has to be a difference, guys. Otherwise, these terms wouldn't have canceled out. One has to be minus, one has to be plus. So we have to have a difference. We have to have different signs here. And then if you have different signs multiplied together, that's a negative. Okay, so let's try it. See if you can factor these for me and then solve it. Okay, see if you can factor those and solve it. 25x squared minus 4 equals 0. First thing I notice is I can't take anything out. 4, greatest common factor of 4, things that go into 4 are like 2 and 4. Neither of those go into 25. But since it's a difference, of two perfect squares, I can factor that into 5x minus 2 times 5x plus 2, right? If I foiled that, that'd be 25x squared plus 10x minus 10x, 0x is in the middle. Negative 2 times positive 2 is negative 4. So then 5x minus 2 equals 0, or 5x plus 2 equals 0. 5x equals 2, so x is 2/5. Or 5x equals negative 2, so x is negative 2/5. Those are the two answers to 25x squared minus 4 equals 0. X squared minus 100, I'm sorry, I gave the answer away. X minus 10, x plus 10 equals 0. Once I have it factored, I have two things that multiply to 0. So either x minus 10 is 0 or x plus 10 is 0. So my two answers are x equals 10 or x equals negative 10. X equals 10 or x equals negative 10. The next one, again, I see perfect square. 9 minus 6x and 9 plus 6x. So either 9 minus 6x equals 0 or 9 plus 6x equals 0. So negative 6x equals negative 9. X equals negative 9/6, which reduces. 3 can go into each of those. So negative 3/2. Here I have, positive. It was negative 9 divided by negative 6, which is a positive 3/2. In this case, I have 6x equals negative 9. X equals negative 9 over 6, which reduces to negative 3/2. So it's 3/2 and negative 3/2. What I wanted you to see is we got the right answer, but what I could have noticed in the very beginning of this particular problem, I could have taken a 3 out. Okay, if you take a 3 out, I'm sorry, I could have taken more than that. I could have taken a 9 out. When I take a 9 out, I get 9 minus 4x squared. Okay, if I would have taken a 9 out first, take the GCF out first, then this is still the difference of two squares. The square root of 9 is 3. The square root of 4 is 2. So I have 3 minus 2x and 3 plus 2x. 9 never equals 0, so I really just have to set 3 minus 2x equals 0, or 3 plus 2x equals 0. My answers then, if I would subtract 3 from both sides, x equals positive 3/2, or 2x equals negative 3, x equals negative 3/2. I got 3/2 and negative 3/2 the other way, but if you remember, I had it as 9/6, the negative 9/6, so it didn't, I had to end up reducing it. If you remember to take your GCF out first, and then you notice it's the difference of two squares, it makes your difference of two squares a little bit easier. Okay, sort of like this one. If I notice, I can take a 3 out first. 3 goes into 3, and 3 goes into 12. So now I have 3 times x plus 2x minus 2. And I can see my two answers are 2 or negative 2 pretty quickly. Then if I would have, here I'd be like, that's not the difference of two squares, right? 12 isn't a perfect square. 3 isn't a perfect square. But once I took the 3 out, I saw it. Okay, try these last 3 on your own. I'm going to pause it. Try them. Okay, we were running out of time, so I just wanted you to see these 3 answers. They're all set up for you. a half, negative a half for the first one, 7 or negative 7 for the next one, negative 5 and 5 for the last one.